Scientific Notation, and Introduction. Dealing with really, really small numbers easily. Would it be confusing, difficult, and possibly lead to errors if you had to multiply the following numbers? This short video will not go into any detail about dealing with really large numbers. You'll have to check out the scientific notation video on really large numbers to see that stuff. Would it be nice if there was an easy way of dealing with really small numbers? Well, you're in luck. There is. The form that scientific notation takes is there's some number followed by some decimal. It's a single-digit number. So we have a single-digit number followed by some decimal, normally then followed by a few more digits. Then there is an exponent, there's a power of 10, and then there is some exponent. If the exponent is negative, then, and this is not necessarily negative, but if there's a negative sign in front of the exponent, the negative sign does not mean that the number is negative. It simply means that the number is small, and we'll take a look at that. First, let's take a look at what a really small number is. 10 to the negative 1 is just 1 in the numerator and 10 to the first power in the denominator. That pattern holds true if we have 10 to the negative 2 is just 1 in the numerator and 10 squared in the denominator. 10 to the negative 3 is just 1 in the numerator and 10 to the third are 10 cubed in the denominator, and so forth with negative 4. We have 1 in the numerator and 10 to the fourth power in the denominator, and likewise with 10 to the negative 5. But what does all that mean? Let's just take a look at that. I have 10 to the negative third. All right, the negative sign simply means that there's a 1 in the numerator. The denominator then simply becomes 10 to whatever the power was. In this case, 10 to the negative 3 is 1 in the numerator and 10 to the third in the denominator. And that's the same thing as 1 1,000ths. We'll take a look at 10 to the negative 9. The negative means that I have 1 in the numerator, and the 9 means that in the denominator I have 10 to the 9th. And that's 1 over 1 billion. 9 zeros. In the English language, we refer to that as billion, but in other languages, they refer to that as a milliard. Now, you try it. Stop the video and try to come up with what the answer is. Then check yourself. 1 is in the numerator, and 10 to the 7th is in the denominator. Your answer would be 1 10,000,000th. Now let's take a look at another one. 1.2 times 10 to the negative 9th. You already know that 10 to the negative 9th is 1 over 10 to the 9th, which is 1 billionth. 1 billionth times 1.2 means that we have a whole bunch of zeros. But how many zeros do we have? Well, we would move the decimal place. It was between the 1 and the 2, so we will move the decimal place 9 times. So there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Why 9? Because there was a 9 as the exponent. Let's take a look at 2.9 times 10 to the negative 6. You already know that 10 to the negative 6 is 1 over 10 to the 6th, which is 1 millionth, and we wind up with 0.00002.9, but that's where the decimal was. So we move the decimal place 6 places. So there's 1, 2, 3, 4, 5, 6. Why 6? Because the exponent was 6. All right, you'll need a sheet of paper and a writing instrument, pen, pencil. Try to express the following number in standard form. Pause the video if you need to pause the video. The correct answer is 0.0000001321. Try to express the following in scientific notation. Try to express the following in standard form. Try to express the following number that is in scientific notation in standard form. Try to express the following number in scientific notation. Your comments, questions, and suggestions are always welcome, encouraged, and appreciated. You may contact me at allenmorris@yahoo.com.